Hello everyone, how are you doing? Making sure everything is going fine. You can hear me. Thank you so much for joining. I know it's a weekday, trying to get through a stream on a weekday during an afternoon is really tough, I know, but thank you so much for joining. I really understand and I really appreciate the effort that all of you are taking to be part of Global Hack Week and throwing love to every other streamer that you see here. Thank you so much for doing that. Well, we give a couple of moments for everybody else to join in. Would you want to tell me where you're joining from? uh, for example, my reply here would be I'm joining from India and it's afternoon here. It's 1:30 p.m. Do you want to tell me where you're joining from and what your local time is? We give it a couple of moments for everybody else to join in. I also have my eyes on the chat. Also, this happens to be my first technical stream for Global Hack Week, so I'm keeping my fingers crossed because technical streams, as you know, it's not a good stream if you have not embarrassed yourself at least once. I'm trying my level best here not to embarrass myself on the stream. Couple of moments here for everybody to catch up. Oh, the chat's now coming in. Hey there, Algeria 9 a.m. Glad you woke up really early. And thank you so much for coming in. To introduce myself, I am Siddharth. I work as a first party events coordinator at MLH. If you've been around for any of the hosted by MLH hackathons that happen digitally on our Discord server, typically every weekend, you might have seen my name appear on the page, or you'd also have seen me as an organizer on the Global Hack Week event pages. Oh, I see more replies popping up. Somebody joining from India. Hello. Hi, hi. Thank you so much for making it. A lot of highs. Looks like all of us are ready to go. Cool. So, just to give you a little bit of overview of what we're trying to do here, we're going to be talking about a little bit of things about computer vision, specifically the library that all of you might have heard of, which is called OpenCV, Open Computer Vision, has been there for quite a long time and it's been a very popular library that all of you would use, and it's also very compatible with other languages. I know folks use it with Python very popularly, but interestingly it's built on C++ on its base, so it's a very powerful tool that way. What we are going to do is we're going to explain and explore certain use cases of it, and these can also be some things that you can go ahead and submit as your challenge for today. You might see a Hey Computer challenge on the challenges page. If there's anybody here who doesn't know where challenges are, any questions like that, please feel free to interrupt me and go ahead and put that in on the comments on the chat, and I'll be happy to answer those. So what's in it for you? We're going to explore the OpenCV library. We're going to talk about a couple of use cases here. If you're someone who loves your pets, if you're someone who is fond of pets, we also have a challenge that can be related to your pets. You can use their images there as well. I'll show you how that's done. We'll also go a little more to kind of understand how object detection would work on a very basic level. Moving on, we'd also explore a library which is called Tesseract. You might have heard of it. It's used for a domain or a world under AI and ML, which is called OCR, which is optical character recognition, which in plain simple words is text recognition. I have a lot of comments pouring in. Let me go quickly see them. Yes, that is where you'll find the challenges. Thank you so much for that. I think we're good to start. Without much ado, let me go ahead and share my screen and then we'll go through things very slowly. Let me get this up. So, to get things started, the first thing that all of us have to be doing right now is to go to collab.research. So, let me just go ahead and explain what this is. You can think of this as a way to run your Python codes. It's very similar to what you do on an IDE. Like you might be using Visual Studio Code. You might be using Sublime Text, and a lot of other Atom being one of the other popular. PyCharm is another popular IDE that you would see. What happens inside of uh, Collab Research.google.com workspace, or this is called as a notebook. What you do inside a notebooks is you would see a lot of cells like this, and what you see here is called a cell. There are two types of cells. It can be a code cell or a text cell. Let me give you an example of what happens. So um, I'm hoping all of you are a little comfortable with Python. If you're not, just let me know, and then I'll be very happy to stop and tell you what all of these terms mean. But let's just go ahead and import a very basic library, which is called the OS library, which helps you to go into your operating systems and select files and all of those things. I think we have a question here, which is what is Google Colab in general? That's what we're getting into. So Google Colab, as a one-liner, is a notebook that you're going to use, that we are going to use here today to be able to run our code. Now, I was just explaining how that would work. So there's a concept called cell, and what you see right now is called a code cell. What you do here is you go ahead and put a couple of lines or a little more than a couple of lines inside of here, and then you're going to run the cell. Unlike what you do inside of your regular IDE, you do not run the whole file together, but you run the cells together. How does that help? While you run each of the cells, you're able to print the output for a particular cell. That also makes debugging very simple, because you're not executing the whole file and then debugging the whole file to find out where an error could be. But instead, here you are picking up one cell, running that one by one, and then trying to decide if that runs well for you, right? That's one difference. The second reason why we opt for a notebook which is on the cloud, which Google has for us here, there is also a local instance that you can install, which is popularly known as the Jupyter Notebook, wherein you get all of these things, but you run it on your machine. An advantage with running this, the cloud instance of this notebook, is that you do not have to install a lot of dependencies that we might need during this session. So uh, if you were doing this for the first time on your laptop, you might have to first install Python, which is a big thing to do to begin with. Then you'll have to go ahead and install each of the libraries that we're going to talk about right now. But the good thing about this notebook here is that it's already made available a lot of popular libraries inside of it. So let's just go ahead and pick up the computer vision library that we're going to talk about, which is OpenCV. You import it as CV2. On a typical scenario, you might have to go ahead and install OpenCV, Python, and all of those things. But here, when you create a new notebook, it's there for you already. So even if you are on Windows, Mac, Linux, anything, it's all available on your browser. No setups, nothing complicated. Just go ahead, create a new notebook on collab.research.google.com. I can share the link in the chat for anybody who's working along with me here. Just go there, create a new notebook, and then we can get started. While you do that, I'm going to quickly go back to all the comments here. Yes. Oh, like ID in an interactive mode. That's correct. This is an ID as an interactive way of doing IDs. What is the name of the software? This is called Collab by Google, but generally these things are called notebooks. You might have heard of Jupyter notebooks. Jupyter notebooks are something that you can install on your computer and then work with the cell-like architecture that we were talking about. Oh, I forgot to show you what a text cell would look like. So if you go ahead and click on a text cell, you can then use your Markdown skills to type down anything. So let's just say, this is my first technical stream. Oh, I forgot. You might not be able to see this very clearly. I hope you can see this now. So when you write down something here in the Markdown format, you're going to see the preview right beside it. Markdown is what you use in the GitHub READMEs. And then when you're satisfied with it, you can go ahead and run a cell. Now, a shortcut to run the cell is to press Command Enter or Shift Enter. I'm going to do Shift Enter, and then you see this becomes a text cell. So this another advantage here with using notebooks is that it gives you a combination of text and code cells, unlike the other IDEs where you have to comment. Here you can have a dedicated cell which is more interactive and more intuitive. Now you would not have a way to highlight text and maybe put up links and images and all that in a regular IDE, but the notebook here helps you do that. I hope I was able to explain what IDs are. Alvin is here. Hey, Alvin. Um, I'm just joining the session. We are just getting started. Nothing to worry about. Cool. Can someone confirm if the screen size is something that's legible to you? Can you read through all of the things that's on my screen? Do you want me to zoom in furthermore? Do you want me to zoom out? Is it looking good until here? Giving the chat a couple of minutes to catch up here. Zoom out a little. Okay. Okay, I see a lot of OKs and one zoom out a little. So I'm going to zoom out just a little bit. Here we go. And then I'm going to delete the cell. So if you're not still comfortable with a lot of keyboard shortcuts, you can use these helper tools over here. So this is for deleting one of them. I'm going to delete whatever we don't need right now. So delete this. And then we start with just importing this. But before we start doing that, I'm going to write down some things that we're going to achieve in this session. So because this is the OpenCV one-on-one session, this is what we're going to do. You're going to be introduced to the basic functions inside OpenCV. We are then, oh, I see another question here. You say perfect, that's great. Uh, you've seen CV2 not work well on Collab. That's interesting. I've been trying it out for quite a few amount of time right now. It's not been giving me any trouble. But if you come across any trouble while you're doing things during this session, let me know, and then we could maybe get together and debug it. But it's been working fine for me in general. That's what I've seen. But thank you for bringing that out. Going back, we're going to do some kind of basic introduction to functions, and then we're going to dive straight into projects. Speaking of projects, we're going to first start with, um, I hope it understands that I'm trying to do a numbered list. Yes. So we're going to start with a project that involves your pets. Involves pets. You could always go ahead and submit this for the daily challenge as well. Next up, we're going to do a simple OCR project, which is optical character recognition, and then a little more complicated one, which is going to be about contour detection. Don't worry if all of these things don't make sense to you as of now, but we're going to handle all of this very simply. There's always a little bit of math involved with any function that you're going to see here, but we're going to learn of math just enough to be able to understand what's happening. We're not going to do a lot of maths here, but I'll leave it up to all of your imaginations to go back and feed your curious minds and know what happens behind the scene. So that's our agenda for today. But before we dive into any kind of core, it will only make any sense if we go ahead and first look at the documentation of OpenCV and understand how we can go around it and understand how that works. There's a couple of more comments that I see. Let me go through that quickly. Is it advisable to use Collab as an IDE for developing web application? Um, I don't think that's something that you can do, because here this is made for a completely different use case. What you can do is just, I think you can use this for, if you're using Python, and you probably can use this for debugging your code, because you can have those cells put up differently and then you can run it. But just giving you a random example here, I don't know how accurately this is going to work, but on an IDE, you are able to pick up a lot of extensions and club it together. That gives you a lot more flexibility when you're trying to develop things, right? So for example, let's say you have a VS Code extension that spins up a server for you where you can see your application going live. All that I do not think is possible here, because this was mainly and majorly built for data and ML and AI use cases where you want to run things quickly and look at the outputs right there, right then. But yeah, debugging, yes, but web application development, I don't think so. That's correct. Supports Python only. Um, you can go with R also. Cool. The last comment here. What's the meaning of the third point? We will get to that. But to give you an idea, let's just say we have a image that has 3 or 4 objects. Okay, let me make this a little more simpler. Let's say we have a photographed image wherein we have a receipt or a bill, and then a couple of other noisy objects, which is when I say noise over here, these are all the things that we do not want it to be there, and there's something that we're not interested in. So let's say we have a receipt in a particular thing, we have, let's say, a mouse and a keyboard, and the thing that we are interested in is only the receipt or the bill. What we will do with contour detection and perspective transfer and all of those is to figure out the region of interest, which in this case is a receipt, and then be able to get some information out of this. So basically clearing out all of the noise, picking up our region of interest, and then be able to do some kind of processing on it. I hope that makes sense, but we'll get to a little more detail on it while we reach there. So hang around and then just relax for now. Cool, great start to that. Just one other concept that I want to have all of you understand before we get into this, and I'm going to use an image here which is made available by a website called Ask Python. I think I stopped sharing my screen by mistake. Let me go back and quickly share that. Yes, this. Cool. So this image, let me just zoom into it. So one other term that you're going to hear me use, or you hear the OpenCV documentation use quite a bit, is called the kernel, the one that's mentioned here at the bottom. What you need to understand is the first point here is that every image is is a collection of numbers. You can think of, uh, I think if you have already, I saw a question around web application and things. If you've developed web application, you now know that any image or any color that you try to represent can be a combination of red, green, and blue pixel values, right? Um, Not complicating it a lot, but just understand that any image at the back of it has a lot of numbers. When these numbers get combined together, that's how you form an image, right? So what you see here as a source image, let's just take into consideration, or let's just assume that this is an image that we have right now. And most things that you're going to do with an image processing background or with an image processing intent is going to be a lot of matrix multiplications. Not getting into a lot of complicated things here, but just understand that this would involve a lot of matrix multiplications. Let's say we're trying to achieve a result A, which requires us to go through this process. A can be anything. A can be object detection. A can be removing noise from an image, anything of that sort, right? So every time we want an image to be converted to a resulting image, there's going to be a kernel that we decide on. Kernel is essentially just a n-dimensional array or n-dimensional list, which we multiply with the original image. Just understand that. Now, how does this multiplication work? If you see, this is a 3 by 3 kernel, which is put on top of, if you see this green area here, that means that the 3 by 3 was first put on top of the source image at this position, and then we keep sliding it to different positions. Now, if at the first time we have the -1 value over here overlap with 0, the next time we'll have this one overlap with this -1. So we are just sliding that all across the source image and then getting a lot of multiplication values to fill in the resulting image. I hope that makes sense. I'll wait for all of you to catch up with this, and I'll go look at the chat to see if there are any questions. Um, That's correct. And this process is called convolution. You pointed that out correctly. If you now go ahead, I'm not sure if we have sessions throughout this week about that, but if you go into any of these object detection neural networks or AI models, you will hear of a term called convoluted neural network or convolution neural network. Convolution is essentially this logic wherein you have a kernel which is put on top of your source image, and then you slide it through all of the values and then get a resulting image out of it. Um, why we need to multiply with the kernel? I don't think I can explain it directly to you at this point, but we'll get to that. But just keep this in mind that you have some operation that you have to do, which for now, let's take an example of a noise that you need to reduce from a particular image. Let's say to you, this image looks like a proper image, but let's just say this multiplication x that we see over here is a noise for us and we want to remove it. Now, to remove that from it, we construct a kernel of sorts, we construct a multiplication matrix of sorts, and then multiply with the original source image and have a resulting image. Now the kernel here, the numbers here are all just for an example, but the overall concept of how you get a resulting image from a source image for anything that you try to do with images is this, wherein there's a multiplication of a source image with a kernel and you get a resulting image. That is the logic there. Cool. I don't see any more questions here, so I'm guessing we have a go ahead on that. Let's quickly go back and start writing code. So we've now understood that, oh, I keep ending my screen share, I'm sorry. Yeah, here. Cool. So the couple of libraries that we're going to need, one of them is of course CV2, which is the OpenCV library. We're also going to need something called Numpy. I think we've had somebody was here before me to explain a lot of libraries around this. But if you don't know what NumPy is, if you are completely clueless of how NumPy works, NumPy is just a library that helps you represent n-dimensional data. N-dimensional could be any n, which is a huge amount of data that you want to showcase. And the other advantage with NumPy is that it helps you do a lot of manipulation in that data very easily, and it's a faster process, unlike you using any other way of manipulating that data set. So NumPy is just another library for numerical manipulations and represents a n-dimensional data set. As simple as that. Now we're also going to import a matplot library, which is just a way for us to showcase images, print images, or any kind of graphs. If you've been around for Will's session on the AI, I think an intro to AI, if I'm not wrong, you might have seen Will play around a lot with this matplotlib function. But just understand this. This is just a graphical library which helps you showcase your graphs or any kind of images. Because we are dealing with images, we might want to print images here and there. So this is an easier way to do it. That's why we are importing this. Now we have all of this ready to go. You can either go, I'm going to scroll this a little bit. You can either go to, okay, you can either go to the runtime option over here and click on run selection to run that cell. Or if you are someone who likes keyboard shortcuts, you can just hit shift and enter. That will run the selected cell for you and then go down to the next cell. The control flows to the next cell. Cool. Any questions here? Just stopping here for a few seconds. Easy peasy. Oh, so the session about libraries is happening after this. School. Just make a note of these libraries. You can always go back and read those documentations, but uh, just understand CV2 is for OpenCV, the one that we want to deal with today. NumPy is to handle a lot of uh, n-dimensional data sets. Matplot library is just a graphical way to represent any kind of data set that you have. And in this case, our data set here is images. So we're going to use that to print images essentially, right? Cool. That's that. Now, to try out things, we'll have to also occasionally import images. So this gives you a way, Collab gives you a way to upload images and then use it for your analysis inside of the Jupyter notebook. So what you're going to do is click on this folder image here, and then this is the upload button here. Click on that. Uh, Select any image that you would want to upload. It will instantly give you a warning that your files are not saved on Collab forever. Whenever your runtime is basically your instance. Whenever your session might be a good word here. Whenever your session on this Collab ends, all of your files are deleted, your variable values and everything is deleted. So never treat this as a permanent way to store your files. Instead, just keep this here while you are trying to use this, but whenever the session is refreshed or the runtime is restarted, your values will get deleted and your files will also get deleted. So we're okay with that. We press OK. And then we should have the file here. So I uploaded a file called mlhbgfinal.jpg. Let's go ahead and explore what this file means. So the first minimum thing that you need to do here is to be able to read a file. Now, if you're not really sure where your file is stored because it's somewhere here, what you can do is click on the three dots over here, click on copy path. That gives you a path that you can directly paste, and then paste your path over here. And then we're going to name this something. So let's say MLH background is equal to CV2.imread, and then we're going to execute that. Now, like we already discussed, this is going to be a collection values. This has to be a collection of values. Let's go ahead and print that to see what it looks like. So if you see, it's an array of essentially a numpy array of a lot of values. If you what you see right now is just zeros because it has kind of cut down a lot of other values because of the size constraint it has in this printing cell. But it's a collection of a lot of values that are in there that constitute this image. Now, if you want to go back and look at only the values that are non-zero, because what we see right now is zero, so we make use of the numpy function or the numpy library and a function called non-zero, and then we just print this variable. Now this will show us the values which are non-zero. So if you see, there's these many values that are non-zero, or these many indexes that are non-zero. Yeah, that's that. But what we would want to do here is go ahead and print and display the image that we have. So we're going to now use the library which we imported, which is called matplotlib. And because we have imported it as plt, the keyword, we're going to use plt.imshow and then print it there. Cool. So this is the image that we uploaded, but this might look a little different to you. If you notice, this is the exact image that I have on my background. If I move a little bit to show you what the logo looks like over here, you would see a combination of red, blue, and yellow. But on the image that we have imported here, it looks different. And you might also notice that there's nothing that I have changed. I've just uploaded it and I've just tried to display it, but it looks a little different. The reason behind that is what the convention that we usually take into consideration is the RGB convention, which means the red, green, and blue in that order. But interestingly, OpenCV takes into consideration a convention which is BGR, which is the opposite of RGB, blue, green, and red. Now, to be able to bring this back to its original position, OpenCV again makes available a function that we can use to convert the BGR image to an RGB image. Let's go ahead and do that. We're going to name it, let's say MLHPG RGB. Then this is the function which says convert color, and original image, which is MLH background or MLHPG. And then the function that's going to help us magically convert this into the RGB format. So it is CV2.color BGR to RGB. And you might have already noticed that the good thing about Collab is that it keeps giving you a lot of prompts, a lot of suggestions, a lot of autofills. So even if you're a little concerned of, or if you're confused with all of the different functions that you see here, just go ahead and type a little bit of what you know, and then it will give you a lot of suggestions. If you notice, the first suggestion here is BGR to RGB, exactly what we were looking for. Now, let's hope that it's converted to an RGB. Now we're going to change this and have this printed as an RGB. Let's see what happens now. Looks amazing. We have what it looks like on my background over here on the stream. This image looks exactly like that. So we now know we are on the right path. Cool. These are all the little things that we wanted to get started with. Now what we're going to do is, because we're going to be printing this or printing images quite often during the session, we're going to create a little function which is something that we're going to going to call every now and then, which will help us print this rather than us having to type down the plt.imshow and all of those things, right? And we'd also have to convert things to RGB whenever we are printing it. So let's just write down a little function. Let's just name it. Um, let's say it's called plot RGB. We take an image as an input, and then what we'll also do is, because I now have to scroll in or I have to zoom in every time to show you the image, I'll also make sure that I by default print images in a bigger format. So there's this function that's provided by the matplot library, matplotlib library, which is called figure, where you can just go ahead and mention the figure size. Now the figure size here is in inches, so you need to make sure that you give it the number of inches that you would want to print it in. So let's just say in this case I want it to be printed as 10 by, let's say 12 by 10, for example. We'll keep changing. We can keep changing it if this doesn't look very good to us. And then finally, we would want to return the image as we did above. We'll do a plt.imshow of the image that we want to print, but we also want to make sure that the RGB to BGR or the BGR to RGB conversion is also taken care inside of it. So what we're going to do it, so we're going to type down this the image, convert it to RGB, right? So what's happening here is first of all, before we return, we convert it into an RGB and then display it. So let's just go ahead and check if this works as we thought it should. So we're going to do plot RGB and then we're going to print image, not image, MLH background, which originally should be right now in BGR. But let's see if it auto converts and then goes ahead and prints it. Works fine. And did you also notice the change in size? It's very zoomed in because we kind of change the sizes to 12 by 10 inches. Now you could always go ahead and play with it to make sure that it looks smaller or bigger, but that's the thing here. Okay, a question here, where can we get the image from? I just picked this image up as an example, but you can go ahead and use any image. If you want to use this image, let me go and share this very quickly in the lounge channel. Just a disclaimer here, we're not going to just stick to this image for the rest of the demo. This is probably the end of when we were planning to use this demo for the last stage of this. But if you want to use this elsewhere, I just quickly share this in the lounge channel. Yes, that's the correct place to do it. And then you can go ahead and I just dropped it there on the AIML Week Lounge channel. I think it's getting uploaded, should be there. But if you'd want to try it out for other things, you can do that. Or just go ahead and upload any random image that you have and should work well. Great. Very easy peasy. We just learned how to read an image. We learned that it's made of numbers. We were able to print it. We understood that OpenCV by default follows a convention of BGR instead of RGB. And we were able to find a workaround where we always would want it to print RGBs because our eyes are accustomed to RGBs, and the images that we produce are also accustomed to the RGB format instead of the BGR format, right? That's what we wanted to start with. Now, when we talked about an image being in the RG, and B channels, you should also know that OpenCV helps you use a function which is called split. Now, the split function is essentially for you to be able to split your image into the different channels it's made of. Now, let's understand what channels are. So we understood that image, MLHPG, for example, here is made of numbers. We did print it. Let's go ahead and explore what its shape looks like, which is essentially the size or the length. Now, if you notice here, it says there are 2160 rows, there is 3840 columns, and oh, I think that I might be mistaken here, because so the easier way to find out which one is the row and which one is the column is to look at the image that we have on the top. So if you notice, the height starts with 0, goes all the way up to somewhere around 2160. So the height is 2160, and then the width of it starts from 0 and goes all the way up to somewhere more than 3500, which looks like 3840. So it's height by width. And then you see there is an additional channel or an additional dimension which says 3, which means there are 3 channels there. Channel is the number of layers to it. Now, we already discussed an RGB image will have 3 channels or 3 layers, the R, the G, and the B, and that's exactly what you see over here as 3. So this also validates that what we have been learning is true, and there are 3 channels, 3 colors that make up a complete image. I hope you know that. Now, We were talking about how do we split this into different things. Now we can split it very easily based on a function called CV2.split. And you might not understand the direct use of it right now, but I just want to put it out there that there's a way for you to split things differently. Now, once you've split it, you can now go ahead and just print your image. Let's say we print the red, we print the green just for demo. So if you notice right now, the red kind of looks like two blues with a green in between, and also make sure we've not converted it the BGR to RGB. That's why you see fancy different colors here. But we'll just go ahead and look at the differences that both of these have. So the red looks like a green in between two blues, whereas the green looks like a blue, a lighter blue, and then a green, right? So just to understand that there are three different color combinations that come together to build this amazing image that we have. Cool. I think it's going all good. Just taking a 2 second pause here to have all of you catch up, and then we go to the next topic. Any questions, feel free to stop me here, because what we're going to go to next is going to be start off our first project, which is the pet project. Hope everybody is doing okay with what we are doing here. Zoom out. I'm sorry. I will zoom out a little bit. Why isn't me letting me zoom out? I'm sorry, I clicked on reload instead of zoom out. I will do that. Yes. Is this okay? Are you able to see both the text and the image together? Are you able to see things more clearly now? Is the text size okay? Not quite sure. I've never streamed with Google Collab on, so I'm not quite sure if you're able to see this very well. While all of you are telling me that, just a little more insight on what the documentation for OpenCV looks like. Let's go there and let's go to OpenCV docs. First, the code. Okay, I'm going to close all of the outputs that we have so the codes appear together. This is what we have been writing for now. I'll keep that there. And then I'll quickly go back to the documentation to show you what that looks like. If you want to take a screenshot for now, you're free to do that. Or I'll definitely be sharing this notebook right after the session. Let's go quickly and look at the documentation. So this is what the documentation would look like. Uh, a lot of sections, a lot to understand, but we're going to just click on OpenCV Python tutorials to begin with. And then there's even more things that we're going to look at. Introduction to OpenCV is the setup of OpenCV. We've already done that. Then there's GUI features, which is learn to display and save images. We also did that. Then there are core operations and then image processing and feature detection. That's what we're going to get to next. So we're probably done with the first two or the first three sections of it. OpenCV's documentation is surprisingly better than what other documentation could be. It looks a little confusing to you, but if you actually go ahead and notice, they have a lot of images because this is an image library. Of course, they have an image that they use as an example, and you're able to see how things change in every step, which makes it a little more interesting for even if it's for the first time that you're looking at it. So do check this out. But we're going to stick to mostly Collab for now, but we'll get back to it whenever it's necessary, right? Um, and the other thing, the good thing about this is whenever you have an H1 tag of sorts, or the Markdown version of H1 that you do for any kind of text cell, you can also wrap everything that comes after it. So if I just click on this drop down thing here, everything under it got wrapped. This helps you make things look cleaner. And now if I go down and then maybe convert this to a text and then have another thing created, you would see that this becomes one section, and then the next header wherever I had it becomes the next session. So it's a very good practice to have a clean code which is understandable by you and everybody else that comes after you to read it. This helps you achieve that goal as well. Now, very briefly, we would want to also look at the drawing functions. Now, because this is an image library, you might have instances where you want to draw a line over it, a circle, an ellipse, a rectangle, maybe also drop some text on it. All of that is made possible by OpenCV. I'm just going to tell you what the functions look like and maybe also explain the parameters to it. We're not going to a lot of detail because it's a very simple thing to understand. The first function here is for you to draw a line on any particular image, which is CV2.line. What you have to pass to it is first the image, then the coordinates of the line, which is the start coordinates. Let's say start coordinates, and then ending coordinates, and then you have to mention the color in which you want this to be printed. Now, because we've been talking a lot about RGBs, your colors also now have to go in the format of R, comma G, comma B. Now, if you know, every color or the maximum and minimum value of colors is 0 to 255, and when you combine the combinations, that's when you get different colors out of it. So let's just say if I wanted only green color to appear on that line, I would say the R to go 0, the green to go 255, and the blue to go 0. So 0 to 55, 0 would mean that it's a green color. Now if I'd want to print red, I would say 255, 0 and 0, and then likewise. And if you mix and match with a lot of numbers, you get different colors going out of it, right? Now the last and the final value that you have to give here is the thickness of the line. Let's just say you have a big image with a lot of colors and your green line is very thin. You can hardly notice it if you're trying to maybe label something or emphasize on something. So you can give it any value, let's say 100 pixels or anything like that, right? That's what you can do with lines. Now, another thing, let's just go ahead and look what it looks like to create a rectangle, because there's a very important lesson in this as well. So, yeah, first of all, you give it image. Then there's a start coordinate, which I'll get to. It's a little different over here. Then there's an end coordinate. We'll get to that as well. And then there is colors. And then there is the weight of the line, which is the thickness of the line, right? Now, to understand the start and the end, let me pull up Excalibur because I would have to draw here. Yes. So, let's pick up a drawing tool. I think this is a drawing tool. This is okay. Let's just say we have a rectangle like this, and I'm surprisingly drawing straight lines. Oh, I'm not. But let's just consider this is a rectangle. Very bad at drawing. Now, the start and the end points here is something that we need to understand on how OpenCV understands how to draw a rectangle just based on 2 points. Now, what we give it is the top over here, which becomes the starting point, and we give it this value over here, which becomes the end point. I'll call it E over here, right? Now, let's just say this is X, Y, or X1, Y1, and let's just say this is X2, Y2. I don't know why it's really hard to type here. X2, Y2, right? Now, let's go back to our notebook and look at an image and understand how that works. Now, let's just pull up a random image from what we just ran. We'll do MLHBG, and then cool. So what we just mentioned was we have the left top and the bottom right that's given as a start and the end point. If you understand why that happens, the left top is the minimum value of you drawing it. If you notice the axis is here, the y-axis, the zero of the y-axis is on the top, unlike what we traditionally do. when we traditionally draw an x and y axis, we keep the x and the y zeros in between, and we call that an origin. But here the origin is basically on the top left. So if you give it a top left starting point, that means that it is the minimum point on that rectangle. And based on that logic, if you give it the right bottom, that is the maximum of both the axes. It's the y maximum and it's also the x maximum. Now, if you want to construct this image out of those 2 points, what you're going to do is, the first point you already have it. For the second point, you're going to keep the y constant and you're going to change the x. Make sense? And then the third point over here, you already have it as the endpoint. Now, for the fourth point, you're going to keep the y constant. You're going to keep the x constant, and you're going to keep reduce the y. Essentially, you play around with the x and the y's, if I was able to tell you. So you just need the two ends, the top left and the bottom right, to be able to construct a rectangle. Give me a thumbs up if that makes sense. I'm going to let you catch up on that. I see one thumbs up. I see the second one coming in. Sounds amazing. Cool. Now let's dive right into our first project, that's around arithmetic operations on images. And we're also going to talk about a term called alpha blending. Now, for this demo, I want all of you, and I'm going to give you a minute here to do that. I want all of you to go pick up an image of your favorite pet from anywhere on the web. Make sure it's not copyrighted for sure. So I'm going to show you how I did it. So I'm going to say copyright free dog images because I love dogs, but you can do any copyright free pet images. Go to, okay, I see a free PNG image over here. I'm going to pick that and go and download any pet image that you want. I'll tell you what we're getting down to, but I want you to go and select any pet image for now. I like this one better, so I'm going to download this, and I have already saved this on my computer. Go ahead and do that. This is going to be your first challenge that you can go and submit to the daily challenge thing. And trust me, this is very simple. Give me a thumbs up if you're done with that. The second thing that you have to do is you need to find a background to an image, which can be where do you want your pet to be positioned. Now you can position your pet in your house, you can position your pet in a park, anywhere like that. What I wanted to do was I wanted to position my pet in a park. So I said copyright free park images, and then I went to one of these links which was actually copyright free images, and then I went there and downloaded a random image there, right? Now, so what you need to do is get a pet's image, or for this matter, I don't think you really need to stick to a pet. Use your imagination, maybe use a superhero image or any character that you want, and then use a background. The background can be your house, your park, or anything of that sort where you want this character or this pet to be positioned in. Get those downloaded and uploaded to um, Collab, because that's where we're going to do this. I have my images with me. So while all of you are going to search for it, I'm going to upload my images over here and then just show you what images I have with me for this demo. And based on the internet speeds and file sizes, it's going to take a little bit of time for the files to upload. So make sure that your files are not very heavy, because if your internet speed is not very strong, it might take a little bit of time for it to catch up and get it uploaded. It's okay to have low quality images. If it's a smaller image, that is the best to have here. Oh, an angry image. Okay. Interesting. Anybody doing anything outside of pets, superheroes, or any creative ideas over here in the chat? Even if you're not doing, if you have any other creative ideas, share it in the chat. Let me see how creative all of you can get. But while you are doing that, I'm gonna quickly import my park and dog image, and then show you what I have, because we already know how we are reading images and how we are printing it. You should be able to do this on your own, calling the plot RGB function, which does a lot of magic for us. And then copy this because we're going to need this for the dog image as well. We're going to call that the doggo image. And then it should be doggo.png. Doggo. Nice. Okay, someone is taking alien generated by Dolly. That is nice. Just make sure it's not a very heavy image. If you try to download it from there, I think it's against their policies to be able to use this. I'm quite not sure. Just make sure it's okay to use images from there. If it is okay to use images from there, I think it would be better for you to screenshot it rather than download it, because screenshots are way less heavier. I don't think it's way less, but it's less heavier than the original images, so you can have that. Ninja Turtles. That is interesting. Cool. We have a really creative audience here. In case you did not notice this, these are my images. The place that I want to position my doggo is in a park, and I don't have a lot of other elements here. No humans, no pets here, so I can have my pet be there, looking very cute. And this is the dog image that I wanted to use, a very cute one. So that is me, the doggo image and the park image. Uh, Give me a quick thumbs up if all of you have your images sorted up, if you have downloaded it and uploaded it to Collab. And you don't really have to print it like this, but you have to read it, the first line essentially. You have that, give me a thumbs up so we can go ahead. Okay, I see one thumbs up coming in. We'll wait for just one more thumbs up to start going in. There's one, there's two. Thank you. There's three. Very good. So we're now going to learn a small lesson here, which is whenever you're trying to do any kind of manipulations on an image, you should be making a copy of your original image just to make sure that the original image doesn't get ruined. Let's say you did not create a copy of the image and you were doing all the manipulations on the original image and it got ruined for some reason. You can always go back and just read it again. Right? That's the very easy solution to have your image come back and get back to you. But it's always easy. So I mean, it's a pain for you to go back and then read it every now and then. So it's always recommended that you create a copy of it using this function called dot copy inside of another variable, get that transferred to another variable and do all of your experiments in that, right? Just run this, so you have your copy ready. And then now what we're going to do is we want this doggo image to be positioned inside of the background image that we have. Now, by now, you might have already guessed that what we're going to try to do is we want to position your foreground image or the image of your character on your background image, which is your background essentially, any place or any premise that you want to set to your character. Now, the layman way of doing it, and I'm going to show you what the problem of doing that is. We're going to make use of direct numpy operations to be able to fill this. I'll tell you how we're going to fill this. But the idea here is we want the park or some values inside the park to be replaced by the values of the doggo image. And that's how we're going to replace it, right? If let's just say I wanted my doggo to be somewhere here, what I want is I want to be able to override all the pixels in the park image over here with my doggo image. So kind of adding both of those together, but not the whole images together. I don't want to override every pixel of park, but a little bit of portion where I want my doggo to be placed, right? How do we do that? I'm going to write a little bit of code and I'm also going to tell you how that works. Now, the other thing that you need to understand is whenever you're trying to do any kind of NumPy operations, the y-axis comes first and the x-axis comes later, because the logic with NumPy is that the rows come first and the columns come later. Now let's go see how rows is y and columns is x. In this case, this image, a row is what goes from the left to the right. Let's just say if this was the 0, my first row is from here till here, crossing the paw. My last row would be from here till here, crossing the head of the doggo, right? So what you see is we are incrementing the height of the image, which is saying that we are changing the y-axis of the image. Make sense? So that is the row, and NumPy here wants rows to be at first. Could you show the code for the park image? Okay. You mean reading it? You don't really have to name it all like that. I named it park because I have a park over here, and this path that I have here is just by clicking here, and then I can just go ahead and do copy path, paste it here, so I get the path on which Collab has stored it, and I'm just printing it here just for all of you to see, but you don't really need to print it. The next thing we did was create a copy of it because we don't want the original value to be spoiled. And then we're now starting to write this, right? So I was explaining why rows would mean y and uh, columns would mean x. So I think you now understand how rows is y, because rows is the height and height means the y-axis. Now on the other hand, if I would want to say what values do columns indicate, columns start somewhere here from this value all the way up till here, and the maximum value of the column could be somewhere here all the way up to here, right? And that is essentially a shift in the x-axis. You increase the number of x-axis, you are basically navigating or iterating through the number of columns that you have. I hope that makes sense. uh, Yes, I know you are way ahead of us, but that's exactly what I was going to demonstrate with this layman thing, that we're going to have a little bit of trouble pulling things together while we do this. But kudos to you for figuring that out. But we're going to get to that very, very, very soon. Not sure why the code for copying the image isn't working for me. Um, can you drop in what you are trying to do? What you need to do is the original value dot copy, and then oops, original value dot copy, and then just put it in another variable. Just put it down in the chat so we can go ahead and debug it. Nice. So we now understand that y is rows, x is column, and we now understand that we want the foreground object. um, Okay, it says none type object has no attribute copy. Can you go ahead and just print your uh, what variable were you trying to do? Yeah, whatever variable you were trying to copy, can you go ahead and print it and make sure, print it or display the image and make sure there is something in it? Because I think when it tries to say it's none type, this could be, oh, you figured it out. Cool, great. Um, let's continue. So let's just say that I want to place this doggo image at 100 units on the x and 100 units on the y. Let's just take that for now, right? So what I'm going to do is I want to be able to start, um, or let's say I want to stick with the y-axis being 0. So I say I would want to start or place my doggo wherever y is equal to 0, and then I would want the whole doggo image to be placed there, which means if the starting value of doggo is 0, the ending value of doggo has to be the height of the doggo, right? So we do doggo dot shape, and we notice when we printed shape, we had three values in it. The the first one was the height, the second was the width, and third was the number of channels. So what we want here is the height. So we're going to say doggo dot shape dot 0. This means that our doggo should be placed where it says y equal to 0, and then print the whole image based on its height. Now that's for the y. For the x, let's say I don't want it to start where it's 0. I want to start it where it's 100, for example. So I start from 100, and then starting from 100, I want the doggo to go all the way up to doggo's width. So we start with 100, and then we go to 100 plus doggo dot shape of, because we use the height there, here we'd want the width to be taken into consideration, so we say shape of 1. I hope that is clear. So what we're trying to do is we just mention the pixels where we want the values of the park to be replaced with the pixel values of doggo. I hope that makes sense. Now if you were able to do all of these things, or you would want to just copy what you see on the screen, after that you can go ahead and print your image, or essentially display your image, and you would now see what someone already pointed out, that you have your doggo in the frame, but the images don't blend really well. It looks like we've just pasted that image on top of it, but we have not blended it to look like an image that was already there. And you can also say that my Photoshop skills don't look really well over here. It looks like I just picked it up and just pasted it over there, but I should be able to blend it really well like that. Uh, okay, I saw someone asking something, but I think that's all now on the chat. So this is not what we want to do. This is where we now talk about a very simple thing, but something that we need to understand, which is called the logic of alpha blending. Now we've talked about three different channels already, the R, G, and B, but we want to now talk about a fourth channel, which is called the alpha channel, which we introduce to the foreground image, the doggo image here, and then manipulate that alpha layer a little bit to make sure that the alpha layer blends well with the background image. Now there is math involved here, but I'm not getting into math. But essentially, how you're going to have this fix this, you want an image I wherein you have to decide a value called alpha, and this alpha into the foreground image plus, hold tight, I'll tell you how this works. And 1 minus alpha into your background image is essentially what you want to do. Now think of it like this. If I decide on a value for alpha which is 0, that means this whole term will go 0, this whole term will become 1, and we are only left with the background image. Now that tells us that if alpha is equal to 0, you're always left with just the background image, and that's not what we want to do. On the other hand, if I say alpha is 1, that means I'm always left with the foreground image, which means I'd only be left with the poor doggo image without any background, right? If I do alpha equal to 1, this is f plus 0, which is only just the foreground image. That tells us that we need to find a value for alpha which should be between 0 and 1. That's the only way we can probably have it blend very well together. I hope that makes sense. um, Yes, I'm going to share the collab with all of you. Don't worry. But if you were stuck somewhere with the code, just let me know. I'm happy to scroll back and show you how that worked. I'm also starting to realize we do not have a lot of time, but that's cool. We will keep covering things as and when we can. Could not broadcast input array from image into shape. Okay. You will probably have to debug that a little bit. I think it's something to do with shapes. If you got this error, um, I'm guessing you got this error in the uh, first copy paste that we tried to do, the arithmetic operation. That could be because of two things. One, because you tried to shift the image too much and it went out of the frame essentially. Try reducing your coordinates that you have. So for us, we had y equal to 0 and x equal to 100. Try reducing that. The second is make sure that your foreground image is not way too big than the background image. The logic here is the foreground image should be smaller and the background should be larger for us to be able to fix it on top of the background image. I think it should be either of these problems. I see someone also suggesting that. Yes, that's what I was getting down to. Your foreground is probably bigger than the background. Just play around with these two things, and I think you'd be able to find that. If not, if you want me to share the images that I am using, just let me know in the chat, and I can drop it on the Lounge channel where all of you can pick it up from. Or instead, I think I'll just go ahead and drop it right away for anybody wanting to pick it. I dropped it saying images for alpha bending. If anybody would want to get it from there, please feel free to do that. It's on the AIML week launch on our Discord. It worked. You changed the background image, correct? That's how we do it as a team. Great stuff. Cool. Let's get to alpha. We understood how alpha works. Okay, I misspelled alpha. I'm just starting to realize, but yeah, we all know what alpha is. Cool. So alpha, we know that we need to find a very small alpha. So we're going to just implement that there. So we're going to say, because we decided on x offset as 100 and y offset as 0 there, and it doesn't quite look like this is how I want my doggo to be positioned. I want my doggo to be a little down, let's say somewhere around 200, 250 on the x. On the x, yes, 250 somewhere here and then somewhere here. So I'm going to drop random values here for x and y offset, and we're going to have that as a variable because we're going to use this quite often. So I'm going to say x equal to 250, let's say, and then I'm going to say y equal to um, 250. Let's stick with 250 for now. Let's see how that goes. Right, we have both of that figured out. Now if you notice, when we were when we had uploaded the doggo image and when we read it, it was still a 3-channel image, and we now understood that we can't really deal with 3-channel image. We need a 4th alpha channel in the image as well. Now to do that, this is how you do it. When you read that image, let's go back and read it once again. Content doggo.png, that's what's how I named it. You need to have a -1 flag here. I'll show you how that works. When you have a -1 flag and then you try to look at the shape of your image, you will see that there is 4 channels now. So you were telling OpenCV that when you import it, I want you to go ahead and include a 4th channel in it, which I'm going to use as an alpha channel. OpenCV does that for you. You don't really have to play around a lot, right? You do that. Now, since I named it small image, I'm going to name the other as well as large image, and then I'll create a copy of my park into that, right? Now the logic that we were doing of replacing thing, we're going to do that again. So let's say I want my y1 and y2 to be, if you remember what we did here, we were starting with 0 and then going all the way up to doggo.shape of 0. We started with 100 and then 100 plus shape. I'm doing just that, but I'm just doing all that together. Just feel free to stop me if this doesn't make sense. We've discussed this once, so I'm guessing you already understand how this works. um, yeah, to shape of 0. Go ahead and do this exact same thing with x-axis as well. We would want to start with a particular value and then have all of the width follow. So f subset plus image dot shape of the width, right? uh, okay, it worked, glad to know. Hi Yusuf, thank you for joining. Cool. I'm hoping you have this figured out, and this is essentially what we did with the other image as well. Now this is where the magic is going to start. We just saw that we need an alpha value, and then we also need to do a 1 minus alpha to be able to multiply with the background image. Now that's what we're going to do. To do that, what we're going to do is we're going to first calculate alpha of the small image, and then we're going to say, I'll tell you what this means. Let me write down the other one as well, and then I'll go ahead and explain how that works. Um, so what we're trying to do here is, because we know the first 3 channels are R, G, and B, this means this is a NumPy way of slicing and indexing. If you've used list in the past, you might have used the colon notation to get some values out of it, particularly, or a range of value. If you were using a normal list, you might have done something like 2 to 5, which means you want to pick up something from a list named S image, and you want only things which start with index 2 and then end at index 4. So you're getting 2 to 4, the indexes. So similar to that, what we're doing here, because this is an n-dimensional array, 3-dimensional basically, what we're doing here is, uh, this says that we want all of the all of the rows, we want all of the columns, but only the three for the three channels that we have, and not really paying attention to the fourth alpha channel here. And we take all of those values and we divide it by 255. Now, whenever you divide something by its maximum value, this process is called normalizing. Why would you want to normalize the values here? Let's say we have values ranging from 0 to 255 all together in several things. When we try to calculate those values, we do operations on it. That's a heavy operation to do because there are a lot of numbers and it becomes a little more intensive to do. If you normalize that with the highest values, you're essentially bringing it in the range of 0 and 1. Let me show you how. So let's say I had 255 as a value, I divided by 255, this becomes 1. If I had 0, which is the smallest value possible, I would have 0. Now anything in between that will be in between 0 and 1. So your complexity of numbers inside of it is way low now, right? Now we have extracted those channels and we have normalized it. So I'll just put down, say, extract channels and normalize it. Uh, I think I did mention right now that we are trying to take out all the three channels, which is incorrect if you notice, because when we put down a number in there, it starts counting from zero. So 0, 1, 2, 3 means that making use of the fourth channel, which is the alpha channel. So what we're doing here is we're picking up all the rows and columns of the alpha channel because it's the alpha channel that we are trying to manipulate and blend with. So we take out all the values from the alpha channel and then we try to normalize it so the complexity of the number is low. Now, why did we do a 1 minus alpha small? Because that's what the alpha blending mathematics tells us. It says do this with the foreground image, but the alpha that you use for the background image, you do a 1 minus for it, right? So you do that. Cool. Once that is done, you just go ahead and implement it in that in that formula that you just saw. So we're going to say for C in range 0 to 3, which means we're taking into consideration the 0th channel, first channel, second channel, and the third channel. And then we want things to be happening on the larger image, which means we will take into consideration the X and Y here. You notice we already had mentioned what x1, y1, all of those things look like. So we just make use of those values that we already had. And we also had the channel because we're iterating through each of the channel that we have. Now just type down the formula that we learned earlier, which was alpha into the smaller image. Take all the rows and columns of whatever channel we are talking about. And then alpha of the larger image, and then whatever channel that we are dealing with for the larger image. I will get back to the chat in a bit. Let me just fix this. I think it looks good over here. Once that is done, we're going to just plot it. Now we are essentially adding the foreground to the background. So all the change is now happening on the background. So if you're able to print this should work. Let me go back quickly to the chat to see if there's anything happening there. Mine gives error for 3. I don't really. Oh, are you referring to this over here? When you try to have the third channel, what you need to do is you need to go and first reread this image with a -1 channel, which makes it have 4 channels. Just make sure you have 4 channels. How do you make sure if it has 4 channels? You print the shape of this variable. If it has 4 channels, you should be able to do this because 0, 1, 2, and 3 should work well for you. If it says 2, I'm guessing your channel right now only has 3 different. I mean, your RGB is only there. You don't have an alpha channel yet. That's why that's happening. I've been there once, so I know that probably you're facing that. But if you are able to get everything fixed, I see a yes. I am hoping that means that was the error that you had. But if you are able to fix this, let's go ahead and run this to see what it looks like now. Fingers crossed here. Okay, we have a problem somewhere here. Let's go ahead and see. It says the shapes is an issue. Okay, I will quickly debug this. What do I? Okay, okay. Start with the range. I was hoping for this to happen anyway. Let's go see why this is an error. Okay. Mhm. I take out the alpha of it first and then multiply with the smaller image. That's exactly what I was wanting to do. And then I take out the alpha of the larger image and then multiply it with a larger image, and then y1, y2 is the same, x next is the same. I should be able to do this. Okay, let's just try running this once again to see what happens if I add it as a tuple. uh, doesn't really change. Cool. That is a nice error to have. Let's just go and quickly run this. If you any of you were able to fix this, let me know, uh, and I'm sure we will celebrate that together. But what we do is, I am guessing the image doesn't fit really well. So just as a precaution, what I'm going to do is I'm going to resize this image, make it smaller because I think it's getting the size of the image is becoming an issue somewhere. So I'm going to make it a little small. So introducing you to the resize image. OpenCV lets you resize images, so you can use the resize image, give it the image variable, and then mention size. So I'd say I would want it to become, if it was originally 550 to somewhere around 800. Let's say I want it to become a 300 and 500 maybe, and then yeah, all of this looks good. Cool. Let's go run that once more. Yes, we did it. So, like I was telling you, the issue was that when I was trying to position it somewhere with the original length of it, what was happening here is it somehow was not fitting well inside of this image. So the error was trying to tell me that, hey, what you're trying to do does not fit on this image. There is a size mismatch of some sorts. But if you are able to run this in this way, you should be able to see your doggo placed there. I still don't like the position here, so I'm going to quickly bring my doggo down a little bit more and then go back to chat to see if any of you were able to get this. And you have. Yes, this is what we were trying to do. My doggo looks very, very cute here, positioned in the right spot. If any of you were able to do this, if you have been following, drop this in the AML week launch right now. So I can probably pick this up for Mary, and I can pick this up and show this on the daily stream today. But if you have any other errors that's going on, let me just go back and look at the chat. Mine is still 2, but 3 in the loop, and it's working fine. Uh, when you say working fine, you are able to produce this image. You are able to blend both the images, and it looks well. If yes, do you mind dropping the image in the AI week, AI ML week launch for all of us to see? Okay, I'll go back and I'll pause here on the code for everybody to look at it, and if you're trying it, to be able to run this and send this across. And this is the first project that we are talking about. I'm quite not sure how many we'd be able to cover today, but you can always send this out as a challenge, not as a challenge, solution to the daily challenge that we have for OpenCV, wherein you are getting two images together using OpenCV, blending them. We learned about alpha blending as well, and then we were able to do this. Okay, you say the image is produced, but it's not blended properly. Do you mind sharing it on the AI ML Week launch? And then probably right after the stream, we can work together to fix it. Or anybody else, if you've been able to do this, share it. If not right now, if you plan to do this a little later, I'm going to share this notebook with you. The only condition here is go look for other images that you find cute, combine all of those together, and then send it across as a solution to your daily challenge. Um, but how cute do you think my image looks? Give me a quick rating out of 5 while I wait for the other person to tell me what issues they were facing. I see one person liking the blending that we've been able to do. It's a PNG and it has a black and white box there. Okay. I think I'll be able to help you a little later after yours, after we are done with the stream, because we'd have to debug it based on the image that you're using. But before we come to the end of the stream, I just want to quickly go through one other thing. I don't think we'll be able to cover everything that was planned, but just one other thing very quickly. And yeah, if you want to share the blend that you have right now, just go share it on the AIML Week launch, and we'd all be very happy to see it. I'll also share mine. You don't know how to join Discord? Okay. I'll drop the link to the Discord here very quickly. Yes, I think. Oh, is there a specific channel for AIML Week? Yes, there is. If you are able to follow the onboarding steps, you will be able to see a category called Global Hack Week. Under that, you would be able to see AIML Week Lounge. That's where I was sharing these pictures that I've been using for this demo. Um, Hey, what's happening here? We are talking about OpenCV and computer vision. We just took two random images and then we combined both of them together to produce this cute image that you see on your screen right now. That's what we've been up to. We are now going to do probably another small project of sorts and maybe call it a day. But feel free to hang around and ask questions if you don't understand anything. It's basic things that we are covering right now, nothing really complicated. And we are picking up projects to be able to learn how OpenCV functions. Cool. I am realizing that you might be planning to do this a little later. That's totally fine. We probably can go ahead and pick up maybe a little more to do over here. So the next thing that you can do over here is to go pick up any image from the web that has text in it. Now, uh, think of it like this: you want your model or you want your code. We do not have a lot of machine learning or deep learning happening here, but you want your code to be able to pick up text out of it. And an ideal case of text on an image is one that's digitally produced. So it's very easy for computers to pick up um, text out of any digital image that you've created. So when you're trying to look for an image, probably look for an image that's photographed by a human and contains a little bit of text here and there. I can't guarantee we'll get 100% of it, but I just want to show you how you use an engine called Tesseract, an OCR engine called Tesseract, to be able to get, um, text out of it. Um, Global Hack Week Lounge is closed. There is a channel called AI ML Week Lounge. Are you not able to see that? Let me go check why it is locked. Um, okay. Did you happen to go to the channel which is called? Okay. Uh, did you happen to go to the channel which is called Join Global Hack Week? If you go to that channel, you will see a little React that you have to do to get access to all the other channels. If you click on that, you get a role for Global Hack Week, and I'm guessing then you will have access to all the other channels. Yes, you should be having access to all the other channels then. You can't verify your Discord. Really sorry to hear that. If you can send us an email at hi@mlh.io. A team member could get back to you and help you fix that. You can't see it either. I am not really sure what's the issue here, but if you can see any channel for raising a support ticket, if you are able to see a category called Get Help, inside of that you will see an MLH support ticket channel. If you go ahead and create a ticket and just mention the issue that you have, you would have somebody get back to you. On the other hand, if you can't see it, just shoot us an email on hi@mlh.io, and somebody from the team will definitely get back to you to help you there. Cool. Let's just go back and quickly demonstrate how Tesseract works. So what we're dealing with here, let me go and type it down for all of you to know how it looks like. So we're dealing with Tesseract, which is an OCR engine. Essentially, OCR helps you recognize text, and OCRs is optical character recognition. Yeah, cool. Pulled in that just for some effect. Or never mind, leave it there. Uh, let's do it. So here is where we probably need to do a little bit of setup. Just running two commands is what I mean by setup here. But Tesseract is not natively available on Collab. So we need to have a couple of commands that need to be run. I am going to drop it over here. This is for you to install the package of Tesseract OCR and then install the Python wrapper of it, which you'll be able to import in your Python codes. Don't worry, this is something that you can just Google and find out. And I'm definitely going to share this notebook with all of you later. So don't really worry if this doesn't happen. The only catch here is that once you have run this, you will most probably be asked to restart your runtime. A copy of this, I'm guessing you mean a copy of the notebook. Yes, definitely. I'm going to send it out to the lounge channel or the announcements for Global Hack Week. I'm going to add it there for all of you to be able to look into it later. And yeah, definitely feel free to share your images that you blend or any kind of OpenCV activities that you do after this. Put it there on the AIML week lounge. I'm sorry, I get that name wrong always. Feel free to drop it there, and we'd be happy to pick that up and feature you on the daily streams. Cool. Getting back to this, like I already mentioned, it will ask you to restart the runtime because you were trying to install something on the kernel level with all the apt and sudo and all of those fancy things. So you just click on restart runtime. It warns you that all of your local variables and things will be lost, which is okay. We can rerun it. Click on yes. You will see a little refresh happening over here. It says initializing, and the refresh is done. Now, if you go and try doing anything of the CV2 sorts, it would say that you can't do it because all of the variables and everything has been refreshed. So we need to go back and start from here where we want to have all of our imports come back, and we will need this function as well, which is for displaying images. So we're going to run that as well. We're going to let all of the other ones be there and go back to Tesseract. Yes. So this installation is done for sure. To make sure if that was done, we're going to import by Tesseract. This should hopefully work. This works. So of course we need an image that has text to be able to read uh, the text out of it. We're going to name it OCR image. You can name it whatever you want. And then I'm going to read an image, which I just put into my Google Colab instance. I'm hoping it's there. It is there. It's called ocr.jpg. To show you what that is, I'm going to print it using the function that we wrote earlier. See how helpful that function is. We don't really have to write the BGR to RGB conversions, or we don't have to write the printing statements every now and then. We just call a function and it does wonders for us. Let's print that out and see what image we have here. This again is a photographed image. This also is a very ideal case where you have text written over there very clearly, not a lot of shadows. I know it's not a very practical use case to take in, but I just wanted to do this because this is photographed and kind of fits our use case. So what we want to do is we want to run this through some amount of code that gives us an output of the text that's mentioned here and says, hey, the text on your image was MacBook Air, right? The most easiest way to do it is to just use the image to string function that's made available to you by uh, PyTesseract or Tesseract, however you want to call it, which is PyTesseract.image to string, and then you pass the name of the image. Is this what we called it earlier? That is true. And then I just put it into a variable which is called text, and then we just go ahead and print text. Let's see how that works. MacBook Air looks good. So it was that simple. You all you have to do is just pick this, and this is not just what Tesseract can do. Tesseract has support for a lot of languages, trust me. And it also gives you the bounding box. Let me tell you what bounding box is. So while we run this to Tesseract was able to look for all of the characters that could have existed on this image, and it found that the characters were just here, and it drew some boxes on it to be able to identify that, hey, this might be a character that I'm looking for. So Tesseract has a function wherein you can also get the coordinates of where the text was inside of it. And this will help you a lot while you're doing other things. Let's just say that you know for a fact that all of the images that you have in your database is for a specific use case. Let's say your electricity bills, for example. Let's say you have a data set of electricity bills and you're trying to get all of the text on it, and you're only trying to look for a particular value that appears in a particular portion of the text of the image. It can be this is a very unsmart way of doing it because you would need to do some training to make sure that you're not hard coding your logic in there. But I'm just giving you a very basic example here where you'd want to pick up the bill value and maybe total all the bill values of everything that's in your data set, and then have a final amount that somebody has to pay. So it's very essential for you to know where this belongs, and you can just go to Tesseracts. Let me just show you how you go and search in the documentation as well, since we're talking about it. Um, that's a very good question. Will it extract text from blurred images? Uh, I'm going to briefly just touch upon some image level operations that OpenCV has for you. I was planning to actually run all of you through all of those things, but I'm starting to realize we do not have enough time, which is completely fine. I can get all of those code inside a notebook and then share it with you later. Just going to run you through some essential operations in OpenCV that help you fix a lot of problems that you have with your images. Problem can be, like you mentioned, it can be a blurred image. There can be text which is not legible, not because of it being blurred, but because of, let's say, a shadow that's on top of it. There might be a lot of different different things inside of your image which you consider noise, and you just want to pick up one region of interest and then get values out of it. You cannot really use OpenCV, and you should be using OpenCV, but you can directly use Tesseract to get text out of it, and it will never give you 100% correct answer to it. We got an 100% correct answer here because the image is quite an ideal one, and it was easy for it to extract things from there. But good question there. I was planning to go ahead and just show you some of these functions that you use and some of these logics that you might need to know while you're trying to do all of these things. Um Cool. I see someone said that the runtime restarted. I'm hoping you were able to find an image for yourself and also run this. Maybe run this over a blur image for sure. Let me get an image like that. Okay. I think I have something like that for you. Um, let's go pick this up. Okay, I have a let's call it a blurred image equal to read it, and it's called blur dot png. I want to plot it for all of you. Let's see the image that I have here. Yes, this is an example of a blurred image that I have right here. Don't worry if you see two different plots here. I actually got this out of a different plot that I had. I just took this out for demonstration purposes. But this plot inside that you see is not actually part of the image. But this again, firstly, is not English. So it uses the English characters, but it's not completely English. So even if it extracts a lot of things that might not make sense to us directly, and while you're trying to use Tesseract on languages other than English, you have to mention that as an additional flag saying what languages can this be. You can create like a list of languages that are probable languages that are going to come inside of your data set, and then have Tesseract go through all of those and kind of estimate what language this can be. We're not going to complicate all of those things, but I'm going to just run this directly through Tesseract and then show you what output we're going to get. It's never going to be 100% correct one here because it's by default very blurred. So the same logic here, I just changed the names. So if you notice, the first text it was able to read was some 1020A0. Let's go look at where that could have been. Um, so I can see a 10 like thing over here, 20 somewhere over here, and then A0 like thing somewhere over here. Right? I don't think there's anything like that on the top. So with the image quality going down, it goes down. Looking at this image, there are a couple of fixes that we should be doing. One of them is sharpening the image a little bit. Uh, we should also be correcting the lighting on the image. There's also a concept called thresholding. Let me just go through all of those things very quickly on the documentation to give you a little bit of idea of what and why we need to do all of those things, because we do not have enough time for a quick demo here. Starting with, let's go to morphological functions. Yes, this should be a good start. Um, this is what I got in for image with OCR. Yes, that's a very good thing to point out there. When you see something of this sort happening, it's probably trying to tell you that either the character that it came across was not a typical English language character. Because of that, it probably did not guess it correctly, or the IDE that you're using does not support that character, which is why it shows you a character like this. If you just Google this, um, I think if you Google the whole thing, \n might be a new line character, but if you Google the other XOC thing that you see, you might see a lot of these Stack Overflow answers where it says your ID was not able to print it, or the character that it extracted was not something that this ID or this Jupyter notebook could print it because it does not understand that character. But you were able to extract some text, that is for sure. The mismatch of character data sets is what is causing that. But good, great that you tried it out. Um, cool. Let's just go through this very quickly. And you will start to understand what all of these things mean. So we are on a topic called morphological transformations. Don't really worry about that. I am hoping you are able to see this. Let me zoom in a little bit. Okay, cool. So just consider that this is the image that we are starting with. Don't think a lot about it. Just consider that this is the image you're starting with. And we're going to talk about erosion first. As the name suggests, erosion means that we would want some of the characteristics of, or some of the properties of the image to be eroded. And that also has some kind of use case over here. How do we erode it? We already talked about kernel, remember? It says the kernel cites through an image. You now should be thinking of the image that we had in mind earlier, which was this, wherein we have a kernel, we have the original image, we place it somewhere on the top, and we are sliding it through the image. Now, specifically for erosion, what happens is when you're sliding this kernel through an image, if wherever the kernel is, the whole area, all of the pixels are 1, if you read through it, you'll know a pixel in the original will be considered 1 only if the pixels under the kernel is 1. So if your kernel has all the pixels as 1, your final result will also have 1. Otherwise, it will be eroded to 0. Because it's a black and white image, you will see that the change here from 1 and 0 would look something like this. And this is not just for black and white images. If you have a colored image, you perform a thing called thresholding. I'll show you what thresholding is. After that, you will be able to reach this stage, black and white or a grayscale stage with any image. But this is what erosion would do to you. You start with an image that's like a thick character of sorts, you get a very thin character. Now, if you're thinking how this is going to help, I'm going to quickly go through another image over here. Let's say we had these dotted points inside of the original image. What erosion is going to do is, while it's trying to erode things or erode properties out of your image, these points will get eroded, which means the level of noise will either reduce or will completely disappear based on the thickness of all of the points. And when you reach this stage, you're going to definitely erode the original character as well. But this is a good trade-off to have. You just erode it a little bit for the noises to disappear, and you will have something like this. Now, the function is something like this: cv.erode. They call it CV here because they import it as CV, but for us, we were using it as CV2. So for us in the code, it would be cv2.erode. You pass an image, you pass a kernel. Now you have to decide what the kernel is going to look like. Here, if you this is another numpy function, don't worry about it. Just imagine that we um, create a kernel, a two-dimensional kernel of size 5 by 5, 5 rows and 5 columns, and then np.ones would mean that everything inside of it is 1 1 1 1 1, something like that. So you create a random kernel. This is a size that you have to decide based on the data set you have. This is more of a hit and trial. You do that, you find the kernel that works the best for you. You can also decide on the iterations that you would want to do. Iterations equal to 1 means the kernel will just slide through all of the values once. You do iterations 2, it slides through things twice, thrice. That's the logic there. And then finally, you will have a value like this, which you have to keep looking at whenever you make a change to any of those values to make sure it works well for not just for one single image that you use, but you have to think big here because we're using a very big data set. Most probably, you have to make sure that this data set, the values that you use, works well across all the images inside of your data set. Uh, I hope I was able to tell you why that's used to remove those kinds of white noises. Uh, Another question here: will Tesseract be able to extract text from human handwritten sentences? If yes, how will it distinguish between handwriting of different people as it might vary? Great question. My answer here would be I don't think Tesseract will be able to get handwritten sentences or handwritten because it doesn't have a lot of uh, handwritten data sets it's trained off for sure. So think of um, Tesseract's ideal use case where the text is produced digitally, but it can be either on a digital image or also on a photographic image, right? If you have a handwritten sentence of sorts or a handwritten text of sorts, that's where we get into more complicated things, which belongs to the neural network or AI category. You then go ahead and do a lot of you create deep learning models. uh, so one of the deep learning models for images, you might have heard of a deep learning model called YOLO, YOLO. You only look once. That's an object detection. I'm just giving you a random example. It's not related to handwriting or handwritten characters here. But YOLO is an object detection model which involves a lot of these machine learning, deep learning algorithms essentially, and gets you identifies objects out of it. So you'd have to train a model like that, a complicated model like that, for it to be able to pick up human handwritten characters, uh, which is possible. There are state of the art models. Talking about it, I would also want to share a very good resource with all of you, which is called Papers with Code. Uh, I just put it here in the chat if anybody is interested. And this is something that I've been following for years now, and it's very very good. The good thing about this is you'll find a lot of research papers for all the state of the art models, all the categories and everything. So if you click on methods right now, you'll see a lot of names that might not make sense to you. We're talking about computer vision now. You will see a lot of computer vision related models. Let's just do a quick search of what this problem was talking about. So let's say handwritten recognition or handwritten text recognition. I click on that, press enter. You will see a lot of these models which have been trained on it. If I click on one of them, the good thing about this is it doesn't really only show me a paper if it's available. It also shows me any kind of code that people might have written based on the paper. So if you are confident enough that you can go and read about a paper and start implementing things by yourself, you can do that. If not, you also have a lot of these open source models that people have made available, which is on this website, that you can go ahead and directly clone and start using. So let's just look at this, which is called BioGPT, because GPT has been very popular. You click on it, you will see the PDF of the paper. You also see a couple of implementations, which is the first of them is officially by Microsoft. This is very helpful for you on your AI/ML journey. So I would ask you to bookmark it somewhere, keep it very safe, because you're going to need this if you want to be able to keep up with the trend of everything that's happening in the AI/ML space. And if you'd want to ever go back and look for a lot of papers or code that you can use in any use case for that matter. Glad you brought that point up, but the answer is the TLDR here is Tesseract cannot. Tesseract might in some cases, but I don't think it can do it in 100% accuracy. You'll have to train some deep learning neural network models to be able to do that. Great question there. Um, cool. We just talked about erosion. We're going to quickly talk about dilation, which is the opposite of erosion, which means uh, you're going to spread out pixels as much as possible. You're going to dilate what you're going to see on your image. So if you notice, we started with an image looking like this, which now looks very dilated. Now, if you are able to follow what erosion is, you now can think of a very easy use case, which is a combination of erosion and dilation, which here is called opening. Now, what erosion opening is essentially erosion followed by dilation. So, let's say we have an image like this, wherein there are a lot of white spaces. We erode this first to make sure all the white spaces go off, and end up probably with an image looking like this, wherein the font weight has gone down considerably. But I want my font weight to go back to normal, so I can use it for use it as a good data set for my machine learning use cases or deep learning use cases. What I'm going to do is I'm going to quickly dilate it, and I'm going to end up having something like this. So if you want to do erosion and dilation separately, you're welcome to do that. If you want to do both of them together, which is in the order of erosion by dilation, you can just use this function called morphology ex. I think I don't know what that means, but you can use this directly, and you can go about that. Now, the opposite of opening is called closing, which is dilation followed by erosion. Now just think of how that would function. You have some noise which is inside of the character and not outside of the character. When it was outside, we eroded and then dilated. But if it's inside of it, we're going to dilate it first to make sure all of these gaps are filled, and then erode it a little to make sure that we did not end up spreading the character a lot, right? Very self-explanatory, but that's how that works. Then there is also something which is the difference between dilation and erosion, which again should be self-explanatory. So when we dilate, we get an image which has font weight bigger than this, and then when we erode, we have something which looks very thin of sorts. When we subtract both of them, we get an empty space in between over here. That's called morphology. Okay, again, this is another way of doing things. Top hat, I don't think is very commonly used, so I'm going to skip that for now. But just one other thing that I want to point out over here is, if you notice, we have been creating kernels on our own, and we've been creating kernels which are rectangular shaped. If you notice, for all the kernels that we used here, it was a 5 by 5, a square essentially, or we are able to make it a rectangle also by playing around with the numbers in the shape. But there are cases wherein we don't really get good results just by a square or a rectangular kernel, and we would want to make it a elliptical kernel or a circular kernel. I can't think of a good example here, but just make a note that there are cases where we would want to do that. In that case, we can use a get structuring element function. We can use that to create kernels for us which will be elliptical or circular or cross also. So if you notice, a regular rectangular kernel looks like this, wherein everything is a one, right? Because it looks like a rectangle there. But if you want an elliptical kernel, this is how an elliptical kernel will look like. The edges somewhere is zero, and then it looks like an ellipse on both sides. There's also a cross kernel, which if you notice looks like a cross, like this, a plus sign essentially. So these are some of the things that you might need to make sure that your images are noise free. Just one last thing that I can think of right now, which I would want to quickly cover, is called thresholding. Let me just pull that up. Um, cool. While we were talking about taking out text or extracting text, yeah, we're probably going to end right on time. While we're talking about taking out text from um, extracting text from an image, we need to understand that the ideal case to be able to take out text from an image is when the image is completely black and white. When and when I say it's completely black and white, it's probably when we have removed a lot of noise from it. So to explain that, let me another question here, which is when working on a model, are we going to use them separately or together? Um, I'm hoping you're talking about dilation and erosion. That depends on your use case. So the first step towards any machine learning or any data related use case is to first investigate and understand. Okay, you were talking about that. Cool. The first step always is to go and investigate and understand your data set very well. And people take days to do that, to understand your data set really really well and look at all the problems that you can generalize across all of the problems that you're facing. uh, After you have looked at that, you need to find out a median or a medium of sorts, wherein you understand what combinations of what operations is going to be good enough for all the images in your data set. You can't really take decision based on one or two images that you've seen. So to answer your question here, this I cannot answer based on the thing that we are doing right now. It totally depends on the data set that you're going to have. But from the things that I have done, I don't think dilation and erosion will work specifically well alone. They go very well separately. But the only place I can remember right now that I've been using it separately is when I was trying to create a data set for a handwritten character thing. So I know we're going a little away from it, but this is a good use case. So what I was trying to do is I was trying to create a word or a word level data set using the handwritten character data set that we have. So if in case you do not know, you can go and look for handwritten um, character data set, and you should be able to see. Uh, why am I forgetting the name? The NIST data set, I think. The MNIST data set, that's it. Okay. MNIST data set. It's not that one. So if you're able to find the MNIST data set somewhere, yeah, this is the one I was talking about. I don't think you were able to see this. So if you look at the MNIST data set, this has both digits and both alphabets all together, but on a digit level. But while I was trying to create for some use case, I was trying to create because I did not have enough data set readily available to me. I had to play around with some things to create a data set for myself. What I was doing is I was taking out a lot of alphanumeric combinations, combining these things together to form an alphanumeric word level character, and then using that to train a text related data, model that I wanted to have. In that case, because I want the text to not look the same every time, I would randomly go and erode some of the values or dilate some of the values, blur some of the values, all those combinations to make sure that it looks very different every time. I don't know if I complicated things more for you, but this is the only case where I could think I was doing things differently because I wanted the data set to look different. But otherwise, I think it goes along very well. Sorry to everybody else who was waiting for me to cover thresholding. But now that I think of it, I might have a better example just to show you what thresholding would look like. Then than having you look at everything that's mentioned over here. Let me just quickly pull that up and then we can call it a day, hopefully. Okay. Cool. This is a notebook that I had built earlier, which covers a lot of things that I wanted to discuss today, and I hope you're able to see it well. Uh, cool. So, a use case that I talked about to begin with was this, wherein we had a lot of things in the image. We had a receipt and a lot of other noisy images, and we wanted to get the receipt only left out. In that case, the first thing that we do is we convert it into grays, because more number of colors means that it's going to be very difficult for us to handle. And then I blurred it. Now there is a function to blur the image. We blur the image to make sure that we get rid of a lot of unwanted details that we have, because we are not doing any kind of text recognition of anything of that sort yet. So I blur the image, and then I perform something known as thresholding. This is what I wanted to talk about. Threshold, the word means that you set a limit to something, and that limit, if you go above the limit, something happens. If you go below the limit, something happens. What we do here is this is the value that decides the limit of the threshold over here. So anything that's above 100, the value 100 in any pixel, I want something to be happening there. So I say if it's above 100, I want it to become 255. What we are trying to do is we're trying to normalize this again. Everything that goes above threshold, maybe I want it all to go black. Everything that's below threshold, I want everything to go white. If you notice now, we started with a colored image like this with a lot of noise, but after all of this, we are left with this image wherein there's very little white space, very little noise, and it very well highlights the area that I wanted to pick up, or I wanted to do more investigation on. So this is the use of thresholding, wherein we set a level, set a threshold limit there, and then we play around with the numbers to make sure that we are able to I highlight only what we need. This is also highlight, I agree, but then what we do is we find out contours. I would suggest you go read more about that. We do not really have time to cover that. So I label all the different contours. That contours is basically the boundary or the parameter that we were able to find out from this image over here. And you see, there is very small contours to the very big contour, which is the receipt. If I was able to play around with blurring and dilation and all of those things a little more, we would have been able to get rid of all these different points that we see here. But we should be able to do that. And then finally, I do something. I was able to get this over here. I'll share this this notebook directly, so you're able to look at it. I was able to get this highlighted alone, and then we do something known as the perspective transform. The perspective transform is essentially looking at what we need and then just arranging that to the frame that we need. So after perspective transform, I select this, and that image becomes this. And this is the image that we used for the blurred image tesseract, if you remember. Now, the other thing I was trying to show you is, I don't know if I have an image. Yeah, if you try to extract Tesseract, if you try to run this to the Tesseract engine, you probably will get some sort of values from it. But if you're able to threshold it and get it to a more transparent level where you do not have a lot of colors and shadows and everything, there's more probability of you getting way better results if you do a little bit of thresholding as well. But here in this case, the image is not at all a good one. So this was a failure here, but you will be able to do that as well. Uh, I think we have just a couple of minutes. I'm sorry I had to rush through the last one. I just wanted to show you what this is, but I'll share all of these things to you, and make sure you go ahead and try all of these things, share what you have on the AI ML week launch, and let me know how all of that goes. I'll just take one more question over here and then we'll pass it on to the next speaker. And the question is, can we use it to make a dataset of small image for our deep learning algorithm from a single large satellite image? Can we use it to make a dataset of small images for our DL algorithm from a single? I don't know if I understand that question very well, but uh, I can let's take it up offline. If you're able to get me on Discord, hit me up there, or I can uh, leave my Twitter here. You can if you're on Twitter, just DM me there and then we can take it off. I don't really want to take a lot of time from the next speaker. I'll drop my Twitter here, hit me up, and then we can keep discussing. We'll also, I think you were the one who had some issues with the code as well. We can go about debugging that. Where to find the notebook? I will send it across on the announcement channel and tag all of you so you have access to that. Uh, but thank you so much for hanging around. I know this was a very technical heavy session. I am hoping that I was able to help you with the challenges as well. Thanks to you for sticking around. Uh, I had a great time talking to all of you. I think you also had a good time learning with me. See you all later on. Have fun with the next session. Bye bye.